Students, now today let's look at an important example of a refraction, that is rainbow. So it's an interesting example of dispersion, refraction and reflection of sunlight by spherical rainwater droplets. So it's example of all the three phenomena which we have studied so far: reflection, refraction and dispersion. So let's try to see how and when is rainbow formed. When do you actually see a rainbow? If you observe, you will generally see a rainbow after rain. Let's suppose you had a heavy rain, then the rain almost stops, such that one part of sky is almost sunny, whereas the other part is rainy. Now, if you stand keeping your back towards the sun, you will be able to see a rainbow. That is an observation. Now, why that happens, that I will explain you in the next two slides. You will observe it by yourself when the rain stops. Weather is such that the one part is very sunny. You can see the sun there, and some part of sky is still cloudy. Now, if you stand in such a way that your back is towards the sun, in that case, you will be able to see the rainbow in front of you. So in this picture, you can also see a rainbow. One part you can see is a little sunny and the other part is cloudy. Now there are two types of rainbow. One is primary rainbow and the other is secondary rainbow. Both are like the normal rainbow which you would have seen in the sky. The difference between the primary and secondary rainbow is because of the difference in their formation, because of the difference in the way they are formed. That's why they are named as, one is as primary rainbow and the other is named as secondary rainbow. So now we will look at how is the rainbow formed. So let's first look at primary rainbow. Primary rainbow formation. Okay, so it's a stepwise process. Generally, a rainbow is formed after a rain. When there is a rainfall which had taken place, that means there will be some raindrops, some water droplets which are already present in the atmosphere. I also mentioned that it's formed when some part of sky is sunny and that sunlight is present. Now, what happens? When sunlight enters the raindrop, you can see in the figure, refraction takes place. Sunlight is again a white light. So as it enters the raindrop, it gets dispersed into different colors. As you can see that the red end and the violet end got deviated by different angles. Why? Because they have got different wavelengths and they are entering a medium or different refractive index. Right? So refraction of sunlight takes place. In the next step, what happens? Total internal reflection of light takes place inside the drop. Now, why? Now, when the sunlight reach the boundary, total internal reflection takes place. That is, they get internally reflected, and then they again come out from the other end. So what happens here again? Refraction of reflected light takes place as it comes out of the drop, because again there's a change in the medium. So what happened? While entering the raindrop, there was a refraction inside. As you can see here in the figure, as sunlight is entering, refraction takes place. And inside there was internal reflection when sunlight strikes the boundary of the raindrop, it comes back, and that is internal reflection. And again when it comes out from the raindrop to the atmosphere, again refraction takes place. So with the result of this, what happens? Let's suppose if you are the observer, you are standing somewhere. What do you see? You see the light rays which are coming out from the raindrop. For example, when I was talking about refraction through glass lab, I told you that observer always sees the emergent ray. That is, observer always sees the ray which is coming out of the medium. So what is the emergent ray in these cases? These rays which are coming out of the medium are the ones which we see. So the observer sees the constituent colors, right? So what was the input to the raindrop? Input was white sunlight. that is white light. But what was the output? Output is spectrum of different colors because now dispersion had also taken place. So what will the observer see? First, the observer sees the dispersed light. That is, he sees all the seven different colors, right? From all of the raindrops. So as a result, we are able to see a rainbow. Now you can understand why do we see a rainbow after a rain? Because only after a rain you would have so many water droplets in the atmosphere. Why do we see it when one part of sky is sunny? Because then you will have sunlight, and when you have sunlight and raindrops, these are the two necessary things for a rainbow formation. And why are you able to see a rainbow only when you keeping your back towards the sun? That is because if you see sunlight that comes from if you see sunlight that's coming from some side and falls on the raindrop, and then whatever is coming out from the raindrop, if that reaches to your eye, then you will be able to see a rainbow. And it should happen only when you are facing towards the rainbow and your back is towards the sun, then only rays will enter your eye and you will be able to see a rainbow. Now let's look at the formation of secondary rainbow. Let's see what is the difference in this case. So in case of secondary rainbow, also refraction of sunlight takes place at first as sunlight enters the raindrop. Then internal reflection also takes place. Here you can see how the sunlight enters raindrop, and this is how the internal reflection takes place. But in this case, internal reflection takes place inside the drop for the second time. It means it's something like somewhere internal reflection takes place only once, but somewhere internal reflection takes place twice. But however, the rainbow you see will remain the same. There's no difference in the view of primary rainbow and secondary rainbow. It's just that formation of secondary rainbow, in it internal reflection inside the raindrop takes place twice, so it's known as secondary rainbow. And again, when it comes out of the drop, the refraction takes place in the same way. Again, there's a change in the medium. Okay, rest everything remains the same. It's just that in the secondary rainbow, the sunlight enters the drop in such a way that it strikes the boundary of drop twice and bounces back, and internal reflection inside the drop takes place twice. So that is the only difference. So now I hope you are able to understand that when is a rainbow formed, why is a rainbow formed at that time, and how is a rainbow formed. Thank you.